Hey, what's going on, guys and gals? Troy, CheFPV here, ATXRC Productions. Find us on Facebook at Drone Multi-Rotor Reviews, Tips, Tricks, Unboxings. Find us on Instagram. Find us on YouTube at ATXRC Productions, all that stuff. But what we're here to talk to you guys today about is going to be some more 101 and some more intro into FPV, the hardware, what you need to know, and how things interact with each other. So before you go in and upgrade and buying parts and doing all these different things, just to give you a better understanding of terminology, parts, and what you need to know in order to get some troubleshooting done better, or in order to make sure you're purchasing kind of the right products. So this all comes about because there's a lot of questions and a lot of things that people ask me. I've had people ask me questions. I had a guy last week telling me that he had to replace his flight controller, but he used the word one of his flight controllers and something about soldering it up and all this. And I was confused because it just didn't make sense to the question he was presenting me. Well, come to find out, he was talking about an ESC, an electronic speed controller, and not his FC. So that's what brought this video up. So we're going to jump into this stuff. We're going to switch over and take a look. On the desk here, we've got a bunch of different things and some other stuff set aside. But we're going to start by explaining what parts incorporate your copter, what those parts do to work together in order to provide it its ability to fly, and how changing maybe some of those parts or choosing the right part is very crucial in determining how it's going to fly and what you're going to get out of it. So we've got our Let's Race Hobbies Krieger. If you watch the live build, we got this thing about 90% built. It is using a flight controller that is called an SP Racing. It's an SP3 Racing flight controller. It is a F3 flight controller, and not necessarily the one I typically use, but this is one of the ones on the market currently that a lot of people are using. So it's what we put in here for the Let's Race Hobbies. You can get it at letsracehobbies.com. And this flight controller is where we're going to start. It is the brains of the copter. It is basically the computer. It is what takes all of your inputs and determines what they're going to cause the copter to do because of your inputs. And not only when you're inputting, it literally, while just hovering or while flying or trying to fly, determines exactly what commands to send to the ESCs, which are the electronic speed controllers that then control the motors. So everything runs through the flight controller. It commands each ESC independently on how to operate. Now, a flight controller is a piece of hardware. It can contain or have loaded onto it any firmware that is capable of running on that specific flight controller. So, clean flight, base flight, beta flight, race flight, Libre Pilot, Open Pilot before Libre Pilot. These are all firmwares that you can run on different boards. Now, some boards can only run specific firmwares, and some firmwares cannot be run on only but one specific board. So, for instance, Open Pilot and Libre Pilot are pretty much the same thing. They can only really be ran on CC3Ds. Now, correct me if I'm wrong. Maybe somebody out there has loaded one on something else. But to my knowledge, you can only run those firmwares on those boards. But those boards can run different firmwares. The CC3D can run clean flight. In fact, many people don't realize this, but a CC3D on clean flight theoretically is better than a Naze 5. Just throwing it out there. So firmware is the software. It's like your computer. It's the operating system in which your hardware is being ran. It's what kind of determines kind of how your inputs are going to be detected, how they're going to be analyzed, and how they're going to be used to make whatever conclusions and whatever commands are going to be coming out of the flight controller. So don't be confused by the firmware and the hardware. There's another layer to this. The third component in flight controllers is the GUI, or the graphical user interface. Different firmwares use different graphical interfaces. Different boards use different graphical interfaces. However, there's a combination of them that you can use depending on, no matter what your firmware is, as long as the board is specific, you can use, for instance, Clean Flight. You can use the Clean Flight GUI, or the operating system that allows you to make changes and connect to the board and interact with the board. And you can use that whether the board has Clean Flight or Beta Flight on it. You can also, I believe, use that same clean flight GUI for race flight, though there is a race flight GUI these days. Libre Pilot, Open Pilot, those are both graphical user interfaces as well as firmwares on the board. So they're two different things with the same name. So just don't get confused by that. There's three different components in making up what you're using in your flight controller. The hardware, which is the board, the GUI, and the firmware all interact together. So there are also electronic speed controllers. In this case, we are using Multi-Rotor Mania 30 amp ESCs. They are running BL Heli firmware. Which version, I couldn't tell you right this second which ones these are running, but BL Heli is a firmware that the ESC uses to determine its inputs and its outputs based on that firmware. So there's firmware on your flight controller, there's firmware on your ESCs. I will note, do not be so concerned with firmware on your ESCs unless you are a seasoned pilot, somebody that's been tuning and been running these things, or if you're having a problem that you just can't troubleshoot and somebody has asked you to probably go look at it. Do not be concerned with everybody every day is coming out with a new multi-shot and a new one-shot and this and that. Get to flying, okay? If you're watching this video, you're not one of the guys I'm talking to. But if you're watching this video, you're one of the guys I'm talking to. Don't worry about keeping up with the Joneses. Just keep up. Just get up. Get up in the air and fly. That's it. BH Heli, no matter what's loaded on your firmware, typically when you receive them, will be fine the way it is. Same thing with most firmwares, though I do recommend using Betaflight. And I would say that 2.6 is probably the latest one that I would recommend anybody go to. It's pretty stable. I haven't heard any real issues. Or just Clean Flight. I believe it's at like 1.4 or something like that is the one that Clean Flight's currently at. But the way this works is we need to start talking about all of the components now. So I just wanted to say, we've talked about firmware, hardware, graphical interfaces, all the hard stuff we've talked about, all the stuff that's a little confusing and people like to switch around. But how does this all interact as a system? Well, it's quite simple. In FPV, we also have video transmitters. This is a Foxeer 200 milliwatt from Let's Race Hobbies that I put a pigtail on so I could have my Triumph antenna installed, which is my go-to. You always want that antenna installed anytime you power your VTX up, which is a video transmitter, VTX. The TX is the transmitter part, video is the V. Do not confuse that with, again, a radio control transmitter. This is your transmitter that controls the craft using a receiver. This is a Taranis X4RS bus receiver, and this is a Taranis radio transmitter. You could also use Spectrum satellite receiver, and a Spectrum radio transmitter. These transmitters transmit commands to the receiver, which the receiver is connected to the flight controller. It then interprets where it's at and what it's doing currently. And then it also interprets those commands and says, okay, we're going to do this based on that. And to do that, we have to signal this ESC to do this, and this to do this, and this to do this, and this to do that. And now we're doing what we need to do. All of that happens in an instant, obviously, but that is how your copter determines what to do. Now, take FPV into account, and now we're looking through the lens and through the camera. The video transmitter takes a signal from a camera, in this case, again, Let's Race Hobbies HS1177, and it actually is going to take the picture, send it to the video transmitter, and from the video transmitter, send it out in the world, and you collect it on your goggles or your monitor or whatever other receiver, including maybe a diversity receiver or just a standalone receiver, is what receives the signal. So remember, when somebody says transmitter, they may be talking about this, or they may be talking about video transmitter. Make sure you use the right terminology. Two very different troubleshooting issues if you're having them. So we now know how everything works. The motors spin determined off of the command from the ESC, and the ESC gets that command from the flight controller, and the flight controller either gets that command from where it is just doing what it's doing, or from you inputting, one or the other. And that's how your copter flies. Now, people are always trying to make their copter faster, more agile, do better loops, whatever. PIDs, rates, expo, we've talked about it. Get into those before you get into anything else. But you really probably need to know how speed or power and all of that is determined. And I'm going to do my best to explain this, but different things come into effect. For instance, props. We have a ton of different props right here. We have a 6045 from Dahl. This is a 6-inch tri-prop. So this prop is a 6-inch prop with a 4.5 pitch. We've got a 5045, which is a 5-inch tri-prop with a 4.5 pitch. We also have a 4045, which is a, oh, there we go. Sorry. Which is a tri-prop 4-inch variety, very slender, and it is a 4.5 pitch. We have a 4045. It's a blunt nose standard bi-prop. So there's that. And then we have our 5045 Dahl prop, standard bi-prop. And I bring all these up because all of these props produce different amounts of thrust based off of surface area, the speed that they're spun at, and they also have a counter reaction on the load of the copter, which means that depending on which prop you select, means that it's going to change the amount of load on the motor. If it's harder to spin, it'll draw more amps. If it's lighter and easier to spin, it'll draw less amps and spin faster. So it's something to think about, is less surface area on the prop or less weight, either way, is going to spin the prop faster, so it's going to get up to acceleration faster, and it's going to react much quicker. It's going to draw less power and less load, which is going to put less amp draw on the components, and that's what we're going to talk about next. So thrust is definitely determined by the amount of surface area and the type of prop are used, but there's other factors. Things to consider. If you don't know what kilovolts are or how they actually determine the speed of the motor, it's actually very simple. The kV on a motor, when multiplied times the voltage, will give you the RPM. So in this situation, it is a 2300 kV motor. If it's powered by 4S power, we're going to look at 34,040 RPMs per minute. So, or revolutions per minute, RPM. So on 4S, these 2300 kV motors can spin 34,000 RPM. On 12 volts, they'll spin 28,900. So let's say 29,000 RPM. So that's a 5,000 RPM difference by upping the voltage 30%. So in determining you want to go faster, you first determine your voltage. Your props. Can you go faster by maybe propping down a little bit and you get more acceleration, but not as much top end? Can you volt up a little bit and keep your same prop and keep your amps in the right draw and not overdraw amperage for your ESCs or for your battery? And that's where we get into amps and battery fitment and which ESCs to purchase. I'm going to go against the grain, and a lot of guys out there will tell you to get 30 amp ESCs, and you better get 30 amps, especially if you're doing high amp draws and stuff like that. Look, it's true. A 30 amp ESC will protect you in dang near every situation you're going to put yourself in with any of these copters because of amp draw. Because ESCs, though they're rated at what they say they are, will actually burst much higher and actually handle much higher loads. So these 30 amp ESCs will easily handle probably 40 amps at burst and continuously a little more than 30, but they're rated for 30 to be safe. What that means is 30 amps is what the power load it will provide up to for these motors. Now, depending on the power going in, depends on how much it sucks out of that battery and pushes towards the motor, and depends on how much the ESC will actually dictate how much the motor can suck out of the battery. So your ESC is a little bit like the straw on both ends, and you can control the flow by determining by dictating the size of the straw or the ESC. So I personally like to go with 20 amp ESCs for a couple of reasons. I select really good 20 amp ESCs that can handle higher bursts up to 24 and 28 amps, which 28 amps is pretty much the top end that I'm ever really going to draw, though these red bottoms and some other motors are known to draw 30 amps. If provided 30 amps, they will draw 30 amps. So what that means is if I have too many amps on the battery side and I allow it to suck as much out as it can, it could blow the ESC up in between because it's drawing too much power through the ESC. But that's where the proper balance in selecting the right pack, the right ESCs, and the right motors and props. If you're pushing 30 amps on these red bottoms, you're flying pretty darn full throttle, and you're really pushing it and booking it. So yeah, you don't want to do that on a tri-prop probably, or a quad prop, and you probably want to make sure you're not running like a 1345C pack, because you're going to suck that thing dry pretty quickly and probably puff and catch it on fire. But if you select your pack right, you put the right ESCs on there, and you fly it to the way you fly it, and you're not, Conrad flying 1,000,000 miles an hour because you're that badass, but you're not going to draw 30 amps. So just know your amperage, know what it can draw, and make sure you pick components that are going to fit. So ESC amperage, personally, 20 amps for me is enough. I use an XM20 most of the time. It's a great chip, 396F chip, and it's never blown out on me. Battery is where we're going to talk next, and this is key. This is where I see many people make mistakes. Batteries, they cost you an arm and a leg each, man. Y'all should be, first of all, taking care of them. When you crash them, look at them, make sure they're good, check the voltage, check the resistance, but more importantly, just pick the right pack, and it cancels out a lot of the mistakes you can make. If you're going to pick a 1300 pack, make sure it can provide the number of amps you need for your copter at burst, because yes, you are flying at bursts at time, and that's what kills packs. 1300 milliamps divided by 1,000 puts 1.3 amps is what this is rated at. So you can really just move the decimal place. You don't have to do the math, but divided by 1,000, 1.3 amps. You multiply 1.3 amps by the C rating. In this situation, it's a 75C is the low end and a 150 burst. So we're going to take 75C and multiply it by 1.3. That's actually going to give us 97.5 amps is what this pack at 75C, if that's what it's really rated at, will provide safely on discharge. So if I have, I'm going to say instead of the 30 amp ESCs, what if I have 20 amp ESCs? Well, those 20 amp ESCs at standard discharge is going to be 80 amps. 80 amps fits within the parameters of this 1300 milliamp hour battery. But if I have 30 amp ESCs times 4, my minimum amp draw at times is going to be 120. This pack is going to be on the edge, but it is rated for higher because it is 75 150. And I would say that if we're going to pull 30 amps on here, we're going to be pretty high throttle, right? Again, we're going to be Conrad blowing through some gates at like 102. So I'm going to say we're going to average 20 to 25 amps. So in theory, this 1300 will be safe to run it as long as I'm not running it like Conrad and, blowing bottom clips out of here. But it should work. But to be safe, personally, if I was flying a high-powered setup like this, I'm probably running some big tri-props, and I would probably go with a 1550C. That would put me over the hump when multiplied by 1.3. It's going to put me a little closer to the range that I want to be. So just remember, amps for the pack, which is the milliamps, shift the decimal over, times the burst rating, or the C rating, gives you amp draw possible safely out of the pack. That's what's going to keep you from blowing packs up. Don't get the minimum C rating. Get C ratings and pack sizes that match what you're looking at. So if you want to go up in 1550, you can maybe drop your C rating a little bit if you're running 20 amp ESCs. If I was running 20 amp ESCs, I could probably go to a 1550 45 very easily and be safe. That's all we're going to talk about. If you guys want to get more on this, check out Modified RC. Our guy over there did some great work, and I'll put the link in the description on how to adjust or how to pick your packs according to what your flight components are. So go ahead and check that out. That's our show. That's what we wanted to talk about. Guys, when you're upgrading, just know that you can get more out of your copter by tuning it better, picking the proper components, putting the proper props, the proper batteries, and getting it to fly locked in the way that it should fly is going to be the way to first get your copter set up and then decide, do I need to upgrade? Changing a 2300 kV motor to another 2300 kV motor, it's not doing you very much. Changing a 20 amp ESC to another 20 amp ESC or just to a 30 is not going to change how fast your copter technically is flying unless you already had a problem, which means you already had more power available. Just the ESC was the thing holding it back. But that's not what people are doing. Guys are trying to upgrade parts thinking that a name brand is going to be faster than the other name brand. It's not that type of game. These electronics are all pretty much the same, minus some QC, minus some specific components that specific places pick that are higher quality. I'm not saying they're all the same. They all do the same job at the end of the day. One might last longer, one might not blow up and catch fire, but they all technically do the same thing at the end of the day. So it's all about the components and picking them properly and making them match together. Fly safe, fly smart, fly for fun, guys. Fly CheFPV, fly. Let's race hobbies.com. Peace.